All right. Hello, folks, and welcome to AP Statistics. This is our first lesson that we are going to do for today. It's just a little bit of an intro just to get us rolling, and then you guys will have a few problems to work on later for homework. So to start off with, what in general is statistics? A lot of you have heard of this term before. You might have different things associated with it, but what is technically statistics? Well, statistics is all about the study of data. And it can happen in a lot of different capacities, the study of data. And so what that means is that always we are going to be getting data from some individuals, something, we're going to be examining some variables, some sort of individual characteristics of those individuals. And then ideally, we're going to be performing some analysis. We're also going to learn how to represent that data graphically and all those different types of things. I don't want this to show up. Now, when we were thinking about different types of variables that we could examine, the two different types that we will look at are categorical or quantitative. Now, you may have heard of these terms before as well. Categorical variables, you can think of as kind of just categories, right? So this is going to be data that's placed into several groups or categories. All right. And we'll go over some examples in a sec. Versus quantitative data is numerical data. So quantitative data takes number values that are quantities. So often what that shows up in terms of counts or measures, something like that. Specifically, we have two different types of quantitative variables. We have discrete, which are the ones that come from counting something. So actually, I'm going to label this as discrete variables. And they come from counting something. An example of that might be like the number of states that you've visited or something along those lines. And the other type of variable that we may see are, if it's not discrete, it will be continuous. And those are the ones that are going to be measured. So typically, result from measuring something. So something like that could be like your wrist circumference or your arm span, something like that. So right below, you have 8 examples. So I'm going to give you a few minutes. Go ahead, you can pause the video and see if you can identify whether these are categorical or quantitative. And if they're quantitative, see if you can specify if they're discrete or continuous. Okay, hopefully you've had some time to kind of go through those. I'm going to be doing that with you as well. So hair color, that one is going to be categorical. Height, more something that you measure. This one's going to be quantitative. Discrete or continuous, since you're measuring, continuous. Gender, another one that's going to be categorical. GPA, this one's a little tricky, definitely numerical, so quantitative. And this is actually also measurable, so continuous, right? It's something that is measured as an average. Number of cars owned, again, more numerical values here, so quantitative. This is going to be discrete. Blood type. There's only a certain number to choose from, right? This is going to be categorical. Distance that you travel to school, again, numerical. That's quantitative, but you're measuring this. So this is going to be continuous. And this last one, I always like to give as an example because zip code, you are technically using numerical values, right? There's a number that you're using as a zip code, but it's not actually representing anything numerical. You're not counting or measuring anything. Whereas a zip code is just the general area in which you live, which is actually categorical. Okay. So feel free to write out if you have any questions on any of those, or feel free to check in with someone around you. We're going to talk about just a few more things. Now, the way that statistics come to be is that we're always trying to figure something out about some sort of population of interest. So you want to make sure that you identify that first. And then in order to say something about that population, what we do is it can be hard to reach everyone in a population. Let's say you're trying to talk about the population of the United States. It's really hard to get every single person in the United States. So what we end up doing is we end up taking a sample from that population to make it a little bit more manageable and to make inference about. So we collect some data from a sample. Ideally, you want it to be representative, a representative sample. So there's no bias or anything affecting your data. We're going to perform some sort of analysis on it. Later on, you'll learn how to run a test for inference. We may be calculating different percentages, whatever that might be. And then the goal is to be able to say something, make some sort of inference about that population based on the data that you have. So that's kind of the cycle that will frame all of the work that we will do this entire year. And the last thing that we're going to look at for today are diving a little bit deeper into categorical variables. So we're going to talk just briefly about how to display them. So right in front of me, we have some data with radio station genres. So if you look at this first graph right here, this is called a frequency table. Okay. Now, as you can see here, this is a categorical variable. So right here, the genre is your variable of interest. These are all your categories. And then we have what we call counts or frequencies, literally just how many stations fall in each of those categories. So this is frequency, okay, which is also labeled at the top. Over here, very similar, except the difference is that these are what we call relative frequencies. Relative frequencies, another word for percents, or we're just calculating what percentage of the total each of those categories are. And so how do we represent this data? Sometimes when you're just looking at these charts on them by themselves, it can be kind of hard to like compare them or really, analyze. So what we want to do is we want to present this data in a way that could be easily comparable. It could be easier to analyze as well. So two ways that we do that are bar graphs and pie charts. I'm not going to go through how to construct them. I'm sure you've seen them before, but here are two examples. The first one is count of stations. So as you can see, now we've graphed those frequencies on there, and you can more easily compare and see which one's much higher, lower, et cetera, et cetera. Now you can also use relative frequencies for a bar graph. Either one is fine. So you can either use frequencies or relative frequencies. You can even label on your y-axis if you want there. So right here we have, right, frequencies. And then the other option is a pie chart. So as you see here, most often you will not have to construct a pie chart on the AP exam. It's kind of hard to do your circle and try to calculate all those percentages, but you definitely will need to be able to analyze them. So when you're constructing these, last thing for today is that there are some rules to keep in mind. For bar graphs specifically, you want to make sure that the bars are equally wide so that you're comparing them all fairly. You're going to leave a space in between bars. We're going to get into histograms later on, which you don't. So you want to make sure you're not confusing those two types of graphs. Do not replace the bars with pictures or images because that could alter kind of the ratio that the bars are hitting. Might make one look a lot bigger than it actually is. Make sure that you label axes clearly. Always, any graph that we construct in this class, make sure that those are always very clear, and make sure you have a title there. And lastly, for pie charts, all of the pieces in the pie chart must add up to 100%. Make sure you have labels and percentages on there. And you want to use this when data represents parts of a whole. Okay, this is a whole, our total, right, is out of 13,838. Each category is a part of that, and it adds up to it, right? You can see in the relative frequencies how they add up to 100%. We're going to be looking at a few other types of graph next class, but this is just kind of a little bit of our intro. For homework, you will have have to construct a few of these on your own and just kind of classify different types of variables and things like that. If you have any questions on any of this, please feel free to shoot me an email and I will get back to you as soon as I can.